யாராவது வந்தாங்கன்னா கிளாஸ்ல இருக்கான்னு சொல்லிடுங்க. ஆஃப்டர் 3:30.
Yes, sir. Start the program. Yes, sir.
Hello.
Hello, sir. Introduce first of all.
Okay.
Okay, sir. Good afternoon, everyone present for the today's session. My colleague Dr.N.Nandhakumar, Professor Mechanical Engineering, and also Head of PG Engineering Design Department, Government College of Technology, Coimbatore. I warm welcome once again for the today's occasion in this session. I warmly welcome, sir. And
Okay, welcome. Thank you.
And he is presently working at Government College of Technology, Coimbatore. So, in this, for your career, working as Government College of Engineering, Bargur, Kirshagiri, Tamil Nadu, from 2001 to 2004, Assistant Professor of Mechanical Engineering, and also in charge of Mechanical Engineering Department. And then, 4/8/2004 to till date, Associate Professor, Professor of Mechanical Engineering, the Government College of Technology, Coimbatore, Tamil Nadu. And then, the highest academic portfolios for this keynote speaker. Principal in charges of Government College of Engineering, Bargur, within the short period of time worked from 2012 to 13, Professor and HOD in charge of Production Engineering Department, Government College of Technology, 26 2013 to 31/8/2016 varakum. In this time, working as Department of Mechanical Engineering, ME Engineering, that is Manufacturing, PG act as a program coordinator. And then the period of 1/9/2016 to 18, act as Department of Mechanical Engineering UG and also class coordinator. 2018 to 5/2020, act as Engineering Design ME and also PG program coordinator and Department of Mechanical Engineering PG in charges. So, and then up to till date, HOD in charge of PG Engineering Design and Manufacturing Engineering. About the academic activities for the Government College of Engineering, Bargur, Kirshagiri, the actual responsibility, be Mechanical Engineering Program Coordinator, developing research.
Sir,
Yes,
sir, Mani sir, excuse me, Mani sir.
Sir?
Sir, very shortly,
Yes,
introduction
sir.
is over.
Okay,
Okay,
sir.
No, full introduction. Okay.
No problem.
Yeah.
And also the responsibilities and assigned activities in the contribution of the field of higher education. Anna University of Technology, Coimbatore, as a member of Application Inspection Committee for various engineering institutions, acted as verification committee member of Tamil Nadu Government Free Laptop Distribution, deputed as a chief for entrance examination of Consortium of Self-Finance Engineering Colleges, acted as code member for Anna University semester examination, confidential work and other things, SSC government TRB examinations, TNBC and other things. So, and also he published 45 journal papers, published in the national and international paper in international publishers, and also faculty and staff development program, FDP, STP, STTP, attended more than 45. So, now it's hand over to session Dr.N.Nandhakumar. Today handle the topic real world revolution of 3D printing and technology, reality topic. Now it's once again I warm welcome to hand over the session, Dr. N.Nandhakumar sir. Thank you,
Okay, sir. Thank you. Thank you to the coordinator, Professor Mani sir, for giving a wonderful introduction about me. And good afternoon to the participants in the online platform. In this today's session, I am going to present about the real world revolution of 3D printing technology, its reality and possibility. Okay? For the past 3-4 days, I hope all the participants you have come across various types of 3D printing technologies, and you have been aware of from various topics related for the past 2-3 days. So various eminent speakers has presented some topics related to this 3D printing technology. So in continuation of this one, I think I no need to go for any some basics regarding this 3D printing technology. I hope most of the resource person have handled this topic in different fields and different domains. Let me have the what is this reality and possibility. Okay, so apart from this, what is the topics we have seen in our 2-3 days before. This seems to be whether it is possible, whether it is real. So like that, we are going to see that topics which is related to this FDP program. We are using the tool is the 3D printing technology. It's one of the innovative field where this whether it is reality is possible, whether it is possible for us. Okay, so let me start with this presentations. A brief about a small introductions. So some of the 3D printing has a number of changes. It has been gone for so many changes over years globally in and around all the fields. It may be an engineering, medical, as well as social needs. Okay, so as well as this 3D printing technology, as well as this additive printing technology, in future it is going to revolve the entire globally all the manufacturing aspects in the field of engineering, in the field of medical, in the field of as well as for the social needs and as well as for the entertainment needs. Okay, so in the earlier days, the 3D printing seems to be one of the time consuming and costly. Okay, and seems to be it is not very practical for applications outside the industry. And outside the industry means we focus only onto the physical structure of the components, which are the intended for the spare parts or otherwise assembly components, all the things which has been intended. Since because it is a very time consuming and costly, but nowadays it is not so. It is nook and corners, each and everywhere. That's why the topics like this, it's a reality and possibility. So whatever the innovation thoughts you are having in your mind, that innovation thoughts and ideas we can bring into a physical structure. In a physical form, we can bring out this ones. Okay. So one of the largest growth areas in 3D printing is the nothing in the industry is the replacement of parts. Replacement of parts, that is about the spare parts. It is customized. Immediately we can go for the demand of the spare parts. Okay. So there is a tremendous growth, the largest growth in the replacement of parts is in this engineering field, in the manufacturing environment. It may be because of on demand, without the need of storing them in a warehouse. There is no need to store the that is the spares or parts that is the to be intended for the any assembly components. It's no need to go for the storing of the components in the warehouse. Okay, on demand basis we can produce the component. See, nowadays all the automobile industries, automobile global players, those who are in India, they are going for this type of this on demand customer based. It's on demand. Whenever you need, within 1 day, within 2 days, that product will be manufactured, that product will be produced by using the 3D printing technology, and it will be reaching to these destinations. Okay, so which is the most immediate and life among industries currently benefiting from the 3D printing or the medical and the dental industries. Okay, is one of the highly that is the very fastly that is dependent on the 3D printing is that is the field is medical field as well as the dental industries. Now in this presentations also we are going to see a lot of this one's reality, medical realities and its possibilities in this presentations. Okay, so what is a simple thing? We go for this one. It's a use of patients, that is a patient who may be the patient who has been alignments, who are having some medical problems. Okay, so the patient's medical imaging data such as CT scan, by having that CT scan itself, we can go for the creation of the 3D printed medical models. We can even functionalize the organs, functioning organs also we can produced by using this 3D printing technology. Here, what I shown here, this is the one of the this is the gas turbine manufactured. This is one of the, see this one, the structure. It is one of the manufactured by Mitsubishi Hitachi. In this one, the yellow blades are produced by the additive technology. That is a 3D printing the blades, which have been yellow blades. The yellow color, they have been incorporated in this conventional type of this machining itself. They have incorporated the 3D printing. That is the additive manufactured blades in this ones. Okay, below this we are seeing one small. That is the 3D printed vehicle. This vehicle is the 3D printed. It's a customized enterprise car for QA Petroleum. The QA Petroleum is nothing but is one of the Saudi Arabian oil magnate who is having. So this vehicle is one of the 3D printed vehicle. This entire cabin as well as the structure of this vehicle is a 3D printed. Only the it is an electric. It is a battery operated. This one. So this is about a brief introduction of this ones. Okay. When you move on to this, what are the domains? What are the various fields in this applications of the 3D printing as well as the additive term? There is additive manufacturing. It's about this. When you go for the manufacturing application, it's a cloud. It's a cloud. When you go for this master customizations, master customizations, a 10 piece or 50 piece or 100 pieces we can produce at a time having a
Sir, due to voice problem, sir. Voice problem.
manufacturing also.
Sir, not audible. Sir.
Individual, a single piece. That's why you go prototyping.
Sir, audio problem.
Agent
Sir, check it audio, sir.
field is Jalaris, and we are automotive some percent. Most of um,
Sir, having audio problem, sir. Hello, sir. Hello, sir. Sir, check it audio and video. Due to net error, he resolved the problem shortly. Hello, sir.
Sir, yeah.
Audio okay, sir. Video.
Yeah, yeah.
Okay.
So whether we have seen this one, second one, sir.
Okay,
Hello,
sir. Proceed, sir. Visible, sir. Everything visible.
sir. Whether we have seen,
Audio.
whether we have seen this
Okay, sir. Start the program.
second slide.
Yes, sir.
Okay, okay, okay. Sorry for the inconvenience for the participants as well as to the coordinator, since because of this connectivity problems, since here raining, this one. So this is about a brief introductions about this one. And this one we have this. There is one small. There is one photo. In this one is a gas turbine manufactured by Mitsubishi Hitachi. The yellow blades. This one. These are blades which have been incorporated in the conventional. This one blades manufactured which are produced by means of this additive 3D printing technology. As well as this below one, there is a small. There is one electric car which is a customized. Only the customized vehicle. It is according to the manufactured by means of this maybe this by the industry. It is based on the customer. What is his requirement? What is his size? Based on this vehicle has been manufactured by using this. It's one of the QA platform petroleum industry. It is for the petroleum industries. There is one of the Saudi Arabian oil industry. For they have been supplied this type vehicle for the industry. This one. So this and all some when you go for these applications of this one, this is a wider application. As I initially I have told that it's there is a universally this 3D printing as well as the additive manufacturing is widely used in various fields. There is no any specific this field is only used. This field is only used. It is not so. So this is about this manufacturing applications. It's a cloud-based additive manufacturing. It's one of the emerging field when we go for the hello.
Sir, go slowly, sir.
Yes.
Voice is interrupted.
Okay. It is not. Okay, so thank you. So when we talk about this manufacturing applications, as well as medical applications, industrial applications, and social culture applications. Just I have grouped like this and all some applications. Beyond that, this domain, there is a lot of applications widely used. This 3D printing technology is widely used. One thing is the cloud-based additive manufacturing. This is about the 3D printing, cloud-based. This is one of the emerging field nowadays in the latest industries where this additive manufacturing and the 3D printing is a cloud-based method in this one. Okay, so cloud-based method like in most of the automobile industry, they follow this type of an cloud-based additive manufacturing. That means, for example, you take the Volkswagen vehicle. The Volkswagen vehicle, their design, design details, it is not revealed to any of the manufacturing facilities globally around the world. What they will do means, from the head office, they will transfer the design data directly to this manufacturing, to these additive manufacturing equipments, or it may be a 3D printing machineries. Automatically, that the product it will be produced by having this. Is a cloud-based additive manufacturing. One is the mass customization. This one is that is means no need to go for a single piece component production. Rapid manufacturing, rapid prototyping, research, food, agile tooling. This and all manufacturing applications. When you go for these industrial applications, it's about this apparel industries, industrial art, and jewelries. Whereas nowadays the jewelries they are moving towards the 3D printing, help of this 3D printing, lot of innovations, lot of designs are emerging in the jewelries field. Automobile industry already revolving. This 3D printing is revolving the automotive industry, constructions, firearms, computers and robots. Computers and robots, that means some parts, some components. It has been produced by using the additive manufacturing as well as 3D printing, soft sensors and actuators, and even space and satellite also. That is the parts which are the assembled components, some assembled parts which has been assembled in the space and satellite. That type of components is also produced by this additive manufacturing 3D printing. This one is the medical application. It's about this bioprinting devices, medical devices. Pills. Pills is nothing but about the tablets. Even nowadays, tablets, which has been, that means what? The tablets which carry about the chemical composition. It is a confined and defined chemical compositions. That is done by means of this 3D printing technology. That is about the pills. When we go for the social culture applications, it's nothing but about this art and jewelry. Even as I told in the previous slide, it's an art and jewelry. We go for the 3D printing. And there's 3D selfies. That is 3D selfies means what? It's nothing but about this one. What is the image? That is the which has been two-dimensional image which has been taken by us and selfie. It will be replicated into a three-dimensional physical structure that comes under the 3D selfies. Communications, environmental use, research, cultural heritage. That cultural heritage means the old heritage buildings which have been day by day it has been degraded. So that heritage which has been taken as by means of a photo image, it has been CT scanned and further same as cultural heritage profile shapes dimension. It has been produced by using this technology, and we are fixing that one to this. That is the heritages. Okay, specialty materials. Okay, this is about the brief applications of this one. When you go for the real world additive manufacturing scenario, it is about this design freedoms. There is no any constraint. When you go for this additive. That means what? Design freedoms, whatever may be the shape, whatever the profile, it is possible. One by using 3D printing additive manufacturing. That's why call it as a design freedom. One is things weight reductions, customizations based on the customers. We can able to produce these components, fluids and gas delivery. So this is the fluids and gas delivery. There is a conformal cooling and heating pads. This is all conformal cooling and heating pads. So this type of this one, we go for the spacecraft as well as missiles, even this that is atomic power plants. This type of this conformal cooling passages. This is about the cut section of this ones. Okay. And this one's fluid gas, conformal cooling, heating, component consolidations. This is about this component consolidations. This is about the component consolidations. So this is some different various shapes which has been produced as a single integral part. This is not done. It is not possible for us to go for conventional casting, but it's time consuming as well as we can't meet the accuracy. So this profile, you see this one of the impeller which has been a profile shape like this. It is possible by means of the 3D printing additive manufacturing. Okay. So what is telling about this one? This 3D printing additive manufacturing technology. It revolves the entire globally, universally, all the fields. That's why we can see what is about this is percentage of shares, percentage of which rolls the entire 3D printing in industries. Okay. So it spreads across a large number of industries. For example, this one is the motor vehicles, automotive industries. The automobile industry, the percentage of this technology, which technology additive manufacturing is 31.7%. When you go for consumer products, business machines, medicals, academic, aerospace, government, military, and others. These are all some percentage of this additive manufacturing. Here there is another sketch. It's one of the photo image where this world's first 3D printed office building is one of the Dubai. He's one of the owner of this office who has been this office is one of the 3D printed office. It's not constructed by means of an conventional method. This one. This is also one of the world's first 3D printed office building. This is a double-story 3D printed office building. Here, this is one of the automotive vehicles. This is a 3D printed static concept car, first proof of the concept car. That is the possible. It is a reality. Which is the reality is possibility here by seeing these images. See, in this car, this entire body structure it has been manufactured by means of this 3D printing. That is one. Whereas the engine and remaining parts it has been assembled in this one. So this vehicle, this the most the percentage of this structure of this car vehicle, automotive vehicle, it has been produced by means of this 3D printing. So next we can see a small video presentations regarding about this one. This one is the 9.5 meters tall world's first two-story building. It has been built by means of only the 3D printing technology. Sorry. The 640 square meters of this building. This is about this building. Is what we are seeing. This one. This is about the world's first 3D printed office building in Dubai. That's the video presentations. Since shows how this it has been constructed without any conventional type of method of building this one. So that is the reality. So this reality is possible only by means of this technology. Okay? So in continuation of this ones, we can move on to this. Also possible. One of the restaurant space made out of food, especially from the smashed potatoes. Smashed potatoes, they are able to print according to the customers' requirement. Customers, that is the shape, what they shape they required. It is able to produce. So it shows means. So this is customized food that has been designed for foods. There is students from the Delft University of Technology. They have created a 3D printed steel bike. This one is the 3D printed steel bike, which can be produced on demand by means of this one. This bike is produced by means of this 3D printed by means of a metal arc welding technology using this 3D printer. This one university, there's some few group of students. So when you go for these models for the surgeries, surgeons in Mumbai, it's in India, the 3D printing models of a human body parts like kidneys to practice on before operating on the live patients. So they have printed, this is on the printer, the technique which is being done by means of 3D printers, and it can be, that is, it's one of the models which can be used for practical, that is the demonstration of this technique which has been done by means of this Mumbai implants. Okay. After getting approval from the FDA, that is plastic surgeons are using a 3D printed implant. Okay. So this is one of the 3D printed implants. injured persons by getting each of these persons in the CT scan, and then they go for the printing the images of this person's face by means of this 3D printer. And next one is the this is one of the structure of this heart, which has been produced by means of 3D printer. So this is about the 3D printed art bicycle. Okay, as in this previous slide we have seen this one. It's a team of students at the Delft University of Technology, that is in Netherlands. They have created the first bicycle, that is the steel bike, made via the building-based 3D printing technique. It's one of the emerging field where nowadays for a lot of stresses as well as these bridges, it has been done by means of this technology, that is WAAM. So this process is known as wire and arc additive manufacturing technologies. Can a small presentation for this one, video presentations. A team of students, they are designing, before designing of a CAD model, they are designing it. So then they go for this arc additive manufacturing method. Additive manufacturing method for framing the structure of the bicycle. So regarding this presentations, my presentations, you will be seeing seeing a lot of videos. Since that is the videos which use reality, only reality is possible. As my title of this today's session is about this applications of 3D printing technology, where it is a reality and it is possible. You see this one, it is possible by this one. This is the wire and arc additive technology. So this is about this reality. Okay. As nowadays we are, as the universally globally, throughout the world, throughout the country, we are facing about this COVID-19. It's this pandemic spreading of this virus around the global. So in a short period of a time, if you want to go for the that is the production of this 3D printer related occurrences, 3D printer related safety protective equipments, such as that is the physical protective equipments and face shields like this. Okay, so it is done one by means of this 3D printing technology. It's one of the Hong Kong Polytechnic University has been collaborating with the Queen Elizabeth Hospital by having collaborated. The hospital the printed eye shields and face shields. They have produced this about this 3D printer license, because when you go for this customized, it is a short period of time and economically we can go for the production of this 3D printed face shields, or otherwise it may be an personal protective equipment. So this is about this one of the personal protective equipment as well as 3D printing related, that is personal protective equipment as well as the face shield. This one's these are the possibilities, which is a reality, whether it is possible. So there's a small discussion presentations here on this one. Is one of the prosthetic limbs and other body parts when you go for this ones. Okay. A new 3D printed mask. This is a 3D printed mask helped a puppy in California, which heals her face were severely wounded by means of an attacking by means of another dog. So what the veterinary doctors, what they had decided means they have gone for the CT scan of this old puppy, its entire face as well as the head. Then gone for the CT scan image. Then they gone for the 3D printer. Using the 3D printer, they made a small mask. And that is mask is one of the structure which is able to able to fuse the bones of the growth of the bones of the that is the puppies, one of the skeletal puppies. So it's one of the masks is made to help a dog recover from several facial injuries to surgical guides. Okay, so this 3D printed mask. This is the mask. Okay, so the puppy was a 4-month-old female. This puppy's brand is about the Staffordshire Bull Terrier, and it's named as a Loca. Okay? So these engineers, they use the CT scans of the Loca's skull. By having the image, that is the CT scan, they have for the design and development of a customized fit mask, then which has been then printed with a 3D printer. They gone for the 3D printer of this mask. Once they have gone for the 3D printer mask for the dog, and the dog it's served its life by having the 3D printed mask. Why this mask? So it is not since it has the face, it has been several injuries happens to the face of this dog. So what they did means, so it is not possible for this dog to retain the life of this dog. So in order to save the life of this dog, they gone for this method way how we can that is safeguard the life of this dog. Okay? So there is a small video presentations related to this additive printing, that is the face shield for this dog. The right side of the skull and jaw. The 3D printed exoskeleton mask. You see this one? It's a 3D printed mask they are producing. Around 4 to 6 months they are wearing the mask. So the now the CT scan. Yeah. So next another reality, which is possibility, whether it is possible. So it's one of the wondering around this globally throughout the world, how whether it is possible. Something which is natural things, it is not possible. We think of like that, but it is possible by means of this 3D printer. So by experiment conducted by University, Female School of Medicine in Chicago, with birth to healthy pups. The ovaries, it has been artificially they have created these ovaries by means of this 3D printed ovaries. By having this 3D printed ovaries, that mouse it gave a birth to a healthy pups. A female mouse with a synthetic ovaries, they have gone for the synthetic ovaries created on a 3D printer, conceived and gave birth to a healthy offspring. The ovary was created using a porous scaffold made from gelatin. There is a gelatin material used for making the synthetic ovaries. So the gelatin material is nothing but is a porous scaffold where it is able to there is over in this one. So ovaries are referred to as a biosynthetic, that is the organs, because they contain both living material, that is ovarian cells, and non-living material, that is a gelatin. That's why they go for this, that is the synthetic ovaries, where it is made from the gelatins. Okay, so after making this gelatin scaffold means that is about this ovary. The researchers added ovarian cells inside this one, cells taken to the ovary of another mouse. The ovarian cells from the follicles that concentrate hormones and releases eggs. The researchers at last what they finally conclude by researchers is say that the study could lead to an infertility treatment of women with cancers. Even this thing we can go for this. There is the synthetic or artificial way of ovaries. When a person comes in the treatment of this cancer, when she is not able to survive in this giving up this one, so that this is a small this one research which has been conducted and it has been proved by this scientists. That is the 3D printer. It holds one of the vital part here in this this ones. So this is about this mother and this small puppies who was implanted. This mouse was born with an implanted with a 3D printed wall. This ovary was in 3D printed by means of this material. What I was seen in the previous slide. And now person is a Woodruff and colleagues. These are the team members who first removed the ovary of the female mouse, which has been as well. Then they replaced it with the bioprosthetic ovary, a scaffold made by 3D printing technology. That ovary is made by 3D printing technology that could house immature eggs. The implanted ovary proceeded to ovulate and restore fertility to the mouse, which later gives birth to pups, and the mouse moms have been. Even the mouse mom nursed those pups. The researchers noted. That means what? The pups, it has been taken care of these mums. So from this, what's the reality? So it is possible even for this when we go for them artificial type of this this ovary, it is able to give a birth like this. They have been concluded. In future, they are going to that's developing. There is make it for this. And there is a human beings also. If there is any there is a failures or possibilities. So this is the thing. It's one of the using the 3D printing technology.
Real breakthrough here is that we're building a true ovarian bioprosthesis, and the goal of this project is to be able to restore fertility and endocrine health to young cancer patients who have been sterilized by their cancer treatment. Right now we're able to do that with young mice, and the goal ultimately is to provide this back to patients.
Teresa and I both wanted to create an ovary bioprosthesis or some sort of implant. So we said
This is a microscopic look at a bioprosthetic mouse
for exactly this purpose. And Neil Shaw's lab was right next door. No, any collaboration is always great if it's built on mutual respect for each other's work. Scaffolds, if you think about a scaffold for building, they're setting that up and they're building
They made a scaffold for this ovary, creation of this ovary. Gelatin they are used as one of the material. It's a biological hydrogel
We
made
have
from
constructed these scaffolds out of gelatin, and gelatin is just broken down. And collagen is the most abundant extracellular matrix in the body. It's what gives us structure. And the great advantage of doing gelatin over collagen is that it's much easier to process, but it still has the same, what we call bioactivity as collagen. As well as the prayer phase 4, as well as we're trying to investigate how the structure can influence cell behavior and viability. And it also can expand towards other soft organ and tissue engineering applications, because we have the ability to 3D print basically any architecture that we think will be optimal for different cell types. This is an example of one of the scaffolds that
scaffolds.
3D printed, made out of gelatin. First, technician removed the ovary of the mouse, replaced it with our scaffolds, sutured them back up, and we mated some of those animals who were able to have live birth. So this is really the ovary of the suture.
So this is about this one of the possibilities that we can go for the bringing out the reality using this 3D printer. And this is also one of the 3D printer skull implant. That is, they help this 7-year-old boy get back to being a kid. The entire skull of this boy, it has been dramatically damaged. So after going for a surgery, they told that always throughout the life, the kid, he wants to use of this protective devices, helmets, always he wants to do this one. So the 7-year-old Teddy Ward is back to being a normal kid again. It's 2 years after having a tragic fall, almost cost his life, suffered a traumatic brain injury. It left him with a gaping hole in the skull. There's a hole formed with a hole in the skull. So he received a 3D printed skull implant. The skull, it has been printed using this 3D printing technology by having the CT scan of this skull of this boy, and it then it fits perfectly with his existing skull bone. The implant is not an ordinary plastic; it's made from the materials called Coimbatore, which has the roughly the same physical properties as a skull. You can see how this one is a small video for instance.
How Daddy is doing after an innovative operation at Children's Hospital Los Angeles.
This is a boy who gone for the successful implant surgery of this boy. Previously, the boy is always wearing the helmet, and a hole has been formed on his foot. His mother.
This was remarkable. Close to 50% of the skull that's gone.
When the first grader came to Children's Hospital Los Angeles, it had been 2 years since he fell down a Topanga Canyon hillside and suffered a traumatic brain injury, which left
a dramatic brain injury he had this side.
Surgery in our hospital was unsuccessful. So Teddy was sent home for wear a helmet nearly 24 hours a day for more than a year. This is Teddy when we first met him back in August. One of his friends at houses. Being able to go to any clinics was like privilege because no parent wanted the responsibility of a child without a skull. The doctors here had given Teddy the life he had been longing for. Last month, surgeons used a 3D printer to make an implant that would fit perfectly with his existing skull bone. And what they used is no ordinary plastic.
They're using one of the peak materials. It resembles the same physical as that.
Teddy is available because we want to live.
And best of all, he no longer needs the helmet.
So this is about this one of the applications go for this one. Even foods. When we talk about, so since the 3D printer is widely applicable, is widely used in different fields and different domains. So even this food industry is also the 3D printing goes on a vital role, plays a vital role in this. When customers at a candy store in Dubai now using machines from a company German to custom a 3D printed gummies gels in just about any figure they can imagine. So what is the imagination they can have? They can go for the 3D printed image of this. There is one candy, and they can have this ones. You can say a small 3D printed that is candy has been produced. How it implies the technology in this food industries. You can see this one. By having a three-dimensional shape. So they are choosing of their choice what image they are needed. Then automatically it will be printed, it will be transferred to the machine.
Sir, not audible, sir.
So when you go for this biomodules, prosthetics, working organs, there is a lot of development of this 3D printing additive manufacturing. So the degree to which the 3D printing inventions, the bioresorption is truly strategic. This is the persons whose hand limbs, so that the fingers it is not able to function as a normal one. So that what happens, they have been found for the 3D printed this one, prosthetics, there is one structure for this hand which is able to behave like an human. After using this one, they have this behave like a human hand. This one of the another thing. So when you go for the babies suffering from atrasia is one of these new babies have been benefited from medicals. This type of an malaria having person having elements assist the That there is a baby is back for life threatening airway obstructions. So this one is the air obstructions. So for this airway obstructions, they have made a small this we call it as an airway splints. So this splints have been fixed with the airways or fixed in the airways. Now the baby is to breathe obviously having any airway obstruction. This is one of the
Sir,
that
voice is not
printing,
audible, sir.
Hello, sir.
The voice not audible, sir.
Sir,
Voice, sir.
sir, is it audible now? Is it audible?
Audible, sir, but echoed.
Is an echo? Okay. Okay, okay, sir. Is it, sir? Is it clear now? Hello.
Okay, sir.
Hello.
Okay.
Let me continue.
Yes, sir. Continue.
Okay, okay. So it's about the that is the airway splints for children. So this is about some there's a babies, babies. They suffer this type of an trachea bronchia malacia. This type of one of the alignments, the elements which has been that is one of for the beginning of that. So that what happened, the biomedical engineers, one of the Georgia Institute of Technology, they have been creating an institute and this and that is not perfect for a person to go for a normal breathing. So that what happened, they have been this splint that has been produced, manufactured by using this 3D printing. So after having this fix this one to this baby, now after this one, after fixing this one, now this baby is able to breathe without easily. There is no any threatening airway obstructions for this baby life. So this is one of the
Scott, Halster, and I were working on trying to find a solution to this. While we were working on trying to find a solution, I heard about Kaimachi Frito.
Video is not displayed. Videos.
Sir, is it possible? Can you hear? Hello?
Okay, sir.
Hello, sir?
Okay, sir.
Hello, sir?
Okay, sir.
Can you see?
Yes, sir.
Okay, okay, okay. Okay, these pins are created using this one, that is reconstructions of the passions. Yes, okay. So they created what they propose experimentally, which has been done by means of this manufactured by this 3D printed tracheal splint. They have been and expand the trachea and bronchus so that this baby is able to without any obstruction, the baby is able to breathe. So the material which has been is a polycarbonate PCL was determined to be the best material for the tracheal splint. Its time and its capability.
Sir, video display agla.
Hello, sir.
Video not displayed.
Hello, sir.
Video not displayed.
Okay, just a minute, sir. Just a minute. Can you hear me, sir?
No, sir. No video. Only PPT presentation is there, sir.
Okay.
Slide.
Okay. Can you hear me? Can you hear my voice?
Yes, sir. Voice okay.
Okay, sir. Okay, just a minute, sir. Just a minute. There is a.
Scott, Halster, and I were working on trying to find a solution to this. While we were working on trying to find a solution, I heard about Gene Frito. Kaibo was in great distress. He was having episodes where it looked like he might die any day. We were able to get approval to move forward with the split the way that the split was designed to open up and close airway to grow over time. And that is exactly what's happening. The way that the split was designed to eventually dissolve with no
this is one of the 3D printing technology where they have been produced the splint.
It's been 3 years now since we first split.
This is about the 4 months after surgery. Today that baby looks like this.
It's now running around playing with this family. It's wonderful and beyond anything. So after Kaibo, we had 2 other children that had very similar situations like each of us. And to know that we had a process in which we were able to be much quicker outside, and the process went much smoother for the other children. And similarly, been exciting to watch to see as children went from a situation where it was watching these children now able to function well, able to enjoy the time with their families, able to enjoy the holidays with their families. It's so exciting to see.
So this is about this one of the 3D printed. It saves several babies. Not only a single person, saves several babies with breathing problems. Okay. So this is one of the final 3D printed tracheobronchial splint. This is the splint used in one of the baby boys. 3 baby boys with this. This is one of the studies which have been as one of the life-threatening breathing problems are alive today. This one, thanks to the 3D biomaterial, this one of the miracle which has been done in this field of medical field using this 3D printing technology. Medical implant designing to change shape over time. Okay, so that help them keeping breathing. The device is inserted will remain itself, does not need to be removed and dissolved eventually. So there no need to go for the removing of the devices in this this one's there is airways. It dissolves itself. So the research that the 3D biomaterial could one day help those with many disorders. Disorders involving, it may be in heart problems, or it may be bones or muscles or guts, whatever may be thing, there is a possibilities. It's a reality is there. It's a possibility to make everyone's to be there is a free from this type of diseases, and there is no any life-threatening there is alignments which which causes the persons to be end of their life. Okay? So this is one of the this one how this happened. This one's. It's in the year 2018.
He has severe
Tracheomalacia and bronchomalacia. It's one of the diseases.
Really, the problem is that our patients to the point where he couldn't move. Basically, it was almost like he was choking.
So this is one of the problems for the babies.
Fortunately, one of the groups that developed a novel treatment using 3D printed material to support and prevent the floppiness from occurring is actually adhere to our tech now. The first thing we do that we have
so this is about a 3D printing process.
Because we use the CT scan, the image data actually go a digital model of the patient. And from that model, we get the parameters of the length of the collapse segment, the diameter, and use that to actually design the devices. Actually, in this case, there are 3 devices deployed.
Yeah, I think this is definitely going to be life-changing for him and his family.
We were thinking and planning and discussing this for months. This is a well thought out, a well rehearsed, thoughtful approach to what we were doing, just because this is new.
See what is the wonders happening, how the reality. So it is possible, it's life-saving. It's one of the technology which saves you. we are though we are being in the field of the teaching profession as well as this research and development field.
Exactly the right fit. It really is kind of like finding the Goldilocks moment of aha, this is just right. So the things that we implanted go around the outside of the breathing tube to hold it open, and so that it can't be pushed to collapse, and so it allows the free flow of air.
Taking out of this
Georgia should not receive the best types of today, the best innovative care, and we should not have to send anybody out of the state of Georgia. And so I believe that Georgia Tech and other local partners have committed to developing the infrastructure to allow for the delivery of these cutting-edge therapies that, in this case, have been I just saw the medical issues, but he's smiling, before he couldn't even breathe.
This is definitely a rewarding thing to see the patient with his mother. She was not able to hold him for quite some time. That was definitely rewarding.
He's happy, he can be engaging, he can start to be thinking.
So when you go for this about the other construction industries and homes and other buildings, you see this one in, hello, is it audible? Okay. In less than 24 hours, a 400 square feet house was constructed in one of the Moscow with the 3D printing technology. This is the house which has been constructed. This printer which resembles a small crane, it's nothing but a small crane structure. It's there's a cross range structures as well as these feeders, as well as the nozzles, and place layers of concrete mixtures, and the common place that is last for 175 years that is able to withstand the structure of these buildings. Okay, the printer is removed and the installations, the windows, appliances, and roof is added to this type of this structures. Even this construction industries, you see, this is one of the this one's presentations where we go for the there is a construction of this civil industries. So this is about this one of the 3D printing technology. You see this one, additive manufacturing. A home like this can be built in less than 24 hours. That means in 24 hours they are constructing a house at a cost of only $4,000. This is the way how this is using these cranes. This one is the nozzle of a concrete mixture. Is living in poverty and unsafe conditions. We support this one for the poverty and unsafe conditions. So many of the homeless peoples, though we are living comfortably, though we are surviving comfortably. Who is the co-founder for this one?
For many of these families for years, sometimes in their lifetime, they don't have that opportunity to have.
So this is also one of the of the house.
Thanks to modern technology, topics for 3D printing.
Even in your industries or in your institution also, you can go for this type of a small 3D printing concept of building a small rooms or security cabins.
I think I've heard about it. Well, but it's so expensive. I think right now.
So this additive technology have a great future.
Why not? I think it's a good idea. It should be the same, just like other houses. Sounds interesting.
construction 3D printing and its advantages have been known for a long time, but it didn't leave the facilities of closed factories. Existing printers are big and bulky, have a portal design, have high restrictions for printed buildings, as well as are difficult to transport and assemble on site. This is an expensive novelty which could never find a wide application in the construction industry. These printers print only separate walls and sections of buildings, and subsequent assembly is inevitable.
This one is the individual components
This
just
house
for
is
storage.
printed entirely on site. This is the world's first actually printed house. With the advent of Appy's core technology, construction 3D printing opens a new round of evolution thanks to the innovative design of the printer. Appy's core technology consists of a mobile construction 3D printer and automatic mix and supply unit, which combine to make the 3D printing technology easily accounted for competition with traditional methods of construction. The testing was successful and the technology is ready for mass use.
See, these are ribs. This is for strengthening purpose. In between this one, they are making a small ribs. That's strengthening
This
purpose.
time of the year, application of the concrete mixture used as the ink is possible at temperatures from 5 degrees Celsius above zero. The equipment can operate at temperatures as low as minus 35 degrees Celsius. The printed wool surface allows to perform final finishing immediately, which significantly reduces the cost of finishing works. The roof of the printed house, in accordance with the architectural proof, cost about 220 construction sites worldwide.
This is about this. This is about the 3D printing. They feature all these constructions. There's some small images, photo images for this construction industries. This is one of the 3D printed concept home in Austin, Texas. This is one of the wonders where they have been going to construct a more number of houses for this poor people, where they are homeless people, 1 million people. Less than 24 hours, you can build a house. So the team of experts. It's a revolutionizing. It's a 3D printed house. So this is this one. In China, it was unveiled in 2019. It's printed into 450 hours. That means within 450 hours, they have been printed this bridge. It's one of the traditional bridge, which costs about the 2/3 of the usual cost of the constructing bridge by means of the conventional method. When you go for the conventional method, the usual cost will be this one, so that 2/3 they have reduced the cost. And this one, it also installed with the detectors, okay, that relay information about the stress and strain. So there is some detectors, sensor, they have been incorporated inside the 3D printed bridge, stress and strain. So the city can monitor its status in the real time. So this is possible, this is possibilities. Within 450 hours, even the cost reductions, we can go for this type of the bridge which has been constructed in the Texas. It's one of the Chinese countries, Chinese. So this one is a really concrete bridge. level of So yes, segments the after has been established. Even nowadays in our country also the overhead bridges as well as the roads where it has been constructed in different parts of the for this edible, chocolates also, as per the customer requirements, we can go for the 3D chocolate printing into the plastic. It involves, I think, about some ideas for a piece of chocolate art into a 3D model and converting a 3D model into a code. By having this technology, we can have different shapes and profiles of the chocolates, which can be customized, printed by means of the size sliced by a computer program to create layer by layer. So this is how this layer by layer it has been formed. So then Choco Creator, by using one of the Choco Creator, is has been one of the company where they go for this product, and the object will be printed layer by layer, and the 3D model is ready for this construction. So this is also some more images, photo images, where it is small, where it is possibilities for this one. This is one of the images. All the things which has been crafted, which has been made by means of this 3D printing. This is another phone with panel. This one is the integral part. It's a single part. It has been manufactured by means of 3D printing. This is also one of the there is a lid lifter opener. So this is open. So in what way this revolutionary way is 3D printing changing this world? One is the precision medicine. That is creating a personalized organs, which you have seen in the previous slides. Skin grafts, even the skin grafts, suppose damaged skins also we can replace by means of some skin grafts or mechanical parts. They printing to get nanoparticles also we can put from food and pills. So that will be one of the revolutionary ways in which we can go for the precision medicines, microbiome and psychology. So this will be the next way of innovations in personalized healthcare. When we go for the orthogenesis, that is creating an anatomical structures in cell structures. That is one of the even the cell structures we can go for the anatomical changes. The structure we can change the cell structures to intimate the growth of human organs. Even the growth of the human organs also we can alter. That becomes under these are the revolutionary ways. Where it is possible, here they're telling about this possible. It will have counted lives by allowing faster transplants for transplantations, probably without the need of lifelong anti-rejection treatments. Then no need to go for any rejection treatments. 3D printed food, already we have seen this one for assessment. This one. So allowing capture like also food the cartridge for 30 years of shelf life is possible by using only the meals made with the 3D printers. That is meals which contains all the proteins, carbohydrates, vitamins, all the things. So when you go for a custom apparels, okay, what will be the size? It may be a middle of a standard size. Currently, there will be a standard size. Is the demand. So even in nowadays, having a 3D printer in the houses, that's the small parts which are damaged, just everything it can be very immediate and be printed and replace the damaged parts. That will happen even our data. of this 3D printing. One is space program acceleration. Even the space station team so any product has been explorers. So this is about this one of the revolutionary ways in which 3D printing is changing the whether we do it, whether it is possible, it is possible. So we have seen this till now for past around some 30 slides we have seen. So this is also possible. We can't imagine whether it is happening, whether it is possible. Now it is possible. It is a reality. So whatever the thing which is not possible by using the 3D printing and additive manufacturing, it may be possible in future also. Definitely 100% be possible. Right now, because of some difficulties right now, which is not possible, in future it may be possible for these ones. Okay. Customer pulse, space programs, all the things. So this is about brief review of my presentations. Lastly, a small IP protection, intellectual property protections. Okay, so what this IP protection means? Suppose a component which has been designed and developed by so many years, lot of years of research and innovations and time spending. You are releasing that component. You are putting the component and releasing the market. That same component, it can be produced within a period of days, within a short period of a day. How? By having that components CT scan, by getting the images, 2D images, converting into 3D image. That's why we go for this IP protections. Whether there is any IP, intellectual property right protections in the 3D printing technology, no, there is some loopholes. So what they are telling us, intellectual property protection is the major issue. We can't protect it. We can't say that it's an intellectual property rights. It's one of the major issues surrounding the 3D printing and additive manufacturing today. Anything can be done by other companies. I can make some duplicate products. So it has been estimated globally loss of intellectual property because of 3D printing to be over 100 billion per year. This because of this 3D print will be a loss. So user prints near anything we can go for printing, even patented and copyrighted designs very fastly and accurately we go for this printing. So this is one of the issues and challenging when you go for the 3D printing and additive manufacturing technologies. But we can't overcome this one. This IT printing, this intellectual property protections, we are not able to do this. Okay? So this is about, after this is my presentations. I will close my presentations. So my topics, starts with this. This one is the reality. What I told is this one possibilities, which is my 3D printing technology. It makes globally real world revolutions. It gives a revolution of these 3D printing technologies. Sir? Hello, sir?
Hello, sir. This is a very
Okay,
useful
sir.
session, sir. Wonderful one. Nice.
Sir, actually, I want to say one thing. This one, so for the past few days, you come across different topics which are related to in-depth to the technical field, all the parameters, what is the types, methodologies, what is the different categories, all the things we have come across this one. Okay. But this thing, new things we are seeing, wondering whether it is possible. You see this one, even ovaries, we can have some artificial type of ovaries which are able to, in future, there is any infertility problem, it won't be arising. So when you find out the thing about the what is the percentage of this infertility, it happens throughout the globally, universally, throughout the world, there is a lot of issues happening. That is possible only by means of this technology. So there is a lot of innovations when you go for this ones. So I thank this one organizers as well as this ATAL ATAL program for giving me opportunities to share my small presentations among the participants. I hope all the participants if I enjoyed. Since it is a small, Dhananda, there is a small video presentations, so that I hope it won't be boring for you. You have enjoyed these presentations, these ones. So there is a chances, there is an scope for everybody in future that there is an the reality which is we can go for this possibility which takes place, the wonders in the universe. Thank you, sir. Thank you for giving this opportunity.
Thank you, sir. Thank you, sir. Dear participant, if you have any questions for this session, clarify that now.
Sir, I want to ask one question.
Yes, sir. Please, sir.
Sir, just like you have explored other areas, means the food industry and building, the construction industry is very new for me. Means how those industries are different than the mechanical. Whatever the 3D printing technology is available in the mechanical industry, that understood. Those FDM machines and all those machines can be useful for that. But how exactly that works in food industry and civil industry? Can you focus some light on?
Yeah, definitely. Yes, sir. Yes, sir. Sir, it is see this we thought there is no any confined that is defined 3D printing, sir. It is a customized. See, in our department, in a PG design departments, our students of their own, we are going for an 3D printing. It's one of the composite 3D printing by having some small accessories, motors, chains, pulleys, conveyors, nozzles, compressors. So like this, there is no any defined or there is one standard, there is an equipments for this one. So we can go for some customized also based on this need. What is its purpose? There is a customized design. There is structures we can go for it. When you go for the structures, there is a construction of houses. That is because of this. There is truss members as well as these cranes and pulleys, chains, levers. There is a small conveyor belts as well as the there is a rail system. So they are easily able to produce this. This one. Everything is a planned manner. That's all. We want to pre-plan before this process is to be executed to make an what is our ultimate goal? What is our ultimate aim of this component which has been produced? That we can able to produce it by means of an integrating with this. There is a technology as well as result. The only thing is the control system, and we go for the control system is the must for this ones. This one that alone we want to think it over. When is the control systems is we want to have some changes. We want to have some small coding system for the control systems. As we have seen, there's a lot of presentations. There is a different presentations. The videos we have seen this way. There is not any one particular type. There is a lot of type of additive 3D printing types. There is no. They are not using any one particular type. They are going for an different types of different applications. We can go for this ones. So I hope this one there is no any there is one defined or otherwise it may be there is a standard equipment is not there. Even whether you go for the food industries, they can have a customized. So what they are telling about in future, we can go for them food meals in the form of capsules. In another 30 years, we'll be consuming only the capsules. Only we'll be consuming all the proteins, carbohydrates, everything will be in the form of the capsules only. How they go for this capsule will be in the form of the printing only. A small grams of proteins will be added. This ones into the layer, and another layer will be carbohydrates. Another layer will be like this. It will be fused one as a small capsule. After having consuming nowadays, even for this, there is a space shuttle. That is the satellite. Who are living in this long period of time, they are having this type of this proteins and carbohydrates capsules only for that is running their life for 1 or few weeks to retain their life, to withstand that body stamina. They go for this type of capsules. So even it may be in construction industries or whatever the food industries. That is about this customized this demand only. These machines will be customized. So another person, Tarun Singh has a question. Is 3D printing comes under IP or not? So as on date, the 3D printing technology, there is no any IP, intellectual property rights, as well as the machines since. That's why I have given a last presentation. I hope nobody have been touch the topic is one of the challenging issues. The idea, I mean, the 3D printing technologies about this. That is the replica of these products. That is the original products. Replica products that can be in few days or few weeks, the products can be released in the market. So that is the thing about this IP protection. So that's not the 3D printing technology. It won't come this IP. Whenever you go for the patenting, you can patent the product, you can patent the profile, you can get that ones. Okay, but we can't claim for the that is intellectual property right of any IP right for any equipment or any systems. So day by day it is changing. That means what? What is the size, shape, profile that can be made within another couple of weeks. We can produce the components or that equipment itself. We can produce. Okay, sir. Thank you very much for giving this opportunity. Mani, sir.
Thank you, sir. Thank you, sir. Participant, if you have any other questions.
Okay. Thank you.
Okay, sir. Okay. Thank you, sir. Your valuable speeches for the
Okay,
today's
sir.
session is very wonderful one, sir.
Yeah, sir. Okay, I want to say this, whether participants are enjoyed or not seems to be they're boring. Actually, this title this seems to be one of the reality. That is one of the challenging, one of the revolution which keeps the which revolution happens in the all the fields, not only a particular. We are thinking about only the engineering. There is a 3D printing technology. No, it's modern industries, major field we are going for the 3D printing technology, sir. I hope everyone have enjoyed this presentation. Seems to be. Thank you, sir. Mani, sir.
Thank you, sir. Thank you. Yes, sir. Thank you, sir.
So let me leave, sir.
Thank you, sir.
Thank you.
Thank you. Listen, sir. Hello, sir. So all the participants, unmute the video. Unmute the video, sir. Unmute the video. Now it's go for still, sir. Photo system.